Good morning, viewers. Welcome back to our channel SNS Achievement Zone. This is Dr. Abu Bakar Parvez, Assistant Professor, Agriculture Department, SNS College of Technology. Today, we are going to have a lecture series delivered on flow-through conducts in the fluid mechanics and machinery subject. So, let's get into our topic today. Here, the organization of this lecture series goes as follows. What is meant by the flow-through conducts? Need of conducts in the fluid mechanics, the students' need of studying this concept, the scope for implementation of practicality and in real life of this concept, contribution towards the academic research and the industry research, and finally I have an assessment in form of MCQ as well as match the following for your approval. So, what is meant by the flow of through conducts? It is simply conduct means a pipe or a tube or a duct. The pipe may take several forms like circular, rectangular, or any other things. So, conducts can transport two types of flow. One is pressurized conduct flow, which is in case of pipes, and open channel conduct flow, which is in case of channels. Say, let it be rivers or dams or streams. So the need why this is in fluid mechanics is to carry the fluid like liquid, vapor or gases from one point to another, the knowledge of the fluid flow, the interface of the mechanics and the materials needed as prerequisites to meet higher semester courses, analysis of fluid characteristics in terms of computation using mathematical techniques. And students need to study this concept in order to design the project, and startups to gain the knowledge of their flow properties, to understand the fluid properties clearly. Also, the scope of implementation is in medicine field, agricultural field, in case of food technology or food processing fields. Let's have an assessment here. Like in this method of fluid flow analysis, what do we describe the motion parameters at a point? So the answer here is Eulerian method. We describe the velocity, acceleration, pressure, etc. at a point in flow field. And which method is commonly used for fluid mechanics in analysis? The answer is like Eulerian method, because as stated in the previous slide, we described velocity, acceleration, pressure at a point field. Hence, it is also most commonly used in fluid mechanics. What is the liquid flowing through a series of pipe can take up to? It may be answer A, because different diameters, different cross-sectional pipes can be actually utilized when it comes to the flow of liquid through a pipe. Then you have what is the total loss developed in a series of pipe. You have major losses in pipe, you have minor losses in pipe. So answer goes like sum of local losses plus the loss in each pipe, individual pipe. Then you have which among the following is not a loss that is developed in a pipe. So what is it, entry or exit or connection between the liquid velocity? Liquid velocity is in the pipe, which is the velocity which liquid travels through different sections across the pipe. It is a vector quantity, vector field, which is used to describe the motion of the continuum. So the length of flow vector is equal to the flow speed. So it's actually a property, the liquid velocity. So it is not a loss which is developed in the pipe. Major losses and minor losses involve exit, entry, connection, frictional losses, etc. So the liquid velocity is one kind of velocity or one kind of parameter, a vector field, which is never a loss. Okay. So then you have an example which has been given. An example for flow is given in the chart. Like flow can be of internal or external. In internal, it's like pipe flow or open channel flow. External flow is commonly used in like boilers or condensers, etc., where the flow is actually taking part outside of a system. It won't be a closed system anymore. It becomes an open system actually. And what type of conduct is indicated in the sketch? Actually, two types of conducts. In the first slide I told you, like open channel conduct and closed conduct. Closed is like pipes. Here no pipes are involved. You have streams, you have dams, you have rivers in the pictures indicated here. So this type actually falls under open channel conducts. And I have given 7 parameters like density, piezometer, mass density, pressure, the bar and 1 milli. For example, for density it is like T minus 1, option E. Actually, the parameter like kg per meter cube is actually converted to in terms of MLT, dimensional analysis, which you'll be seeing in your third unit. So that density has been matched here. And when it comes to your piezometer, you'll have one limb there, and you have mass density. You have all these to match against. One bar is A, like 10 to the power 5 Newton per meter square. So you can actually match these. So these are the answers which you have actually we have come up with. You can try your math the following before, then you can see the answers here. And the references which we have referred to actually convey this lecture series to you is like the famous RK Bansal book and the Kumar book, as well as I have taken some NPTEL courses and YouTube videos I have followed, so that I'll give a good in a nutshell I can give you the concept of flow of fluid in a conduct. Thank you for watching. Keep supporting. Have a good day ahead. Thank you.